سلام علیکم سلااوتان لێبێ قوتابیانی ئازیز بەردەوامم لەگەڵتان لە تەواوکردنی بابەتەکانی کیمیای پۆلی دوازە سیستەمی ئینگلیزی. دەرسی ڕابردوو لێرە وەستا بووین. So let's begin. Some common industrial acids. Here we have 5 of the most common industrial acids. Remember, we have 5 acids that are very important. One of them, which is sulfuric acid. Okay, we will study all of them one by one. But remember, because I will take them something like some important points about them, their usage, how, or some important properties about them. That's why I don't like to explain all of them for today. So per any lesson, I will try to explain 2 of them. Okay. So today, as the first one. I will start with the sulfuric acid, then we will have something else which is nitric acid. Okay. أمن هميشه ناوكم لنا لو أسيدانا نام لنا أدبي كيمستري. كو أدبي كردي هي شاعرة كان. episode هي لإنجليزي لعربي أدب مان هي لكيمستريش أو 5 important acids مان هي. أنا أدبي كيمستري now. Okay. The first one, sulfuric acid. As you know, sulfuric acid. Or you need to know sulfuric acid, it's a strong acid. Sulfuric acid is the most commonly produced industrial chemical. So if I ask which chemical is the most important that is produced industrially, sulfuric acid. Okay, sulfuric acid. Look at this. Look at this data. More than 35 million metric tons of it are made each year in the United States only. Imagine, only in the United States. So how about Russia, Europe, Asia, okay, example, Iran or the other countries. Okay, the first important point about the sulfuric acid is used in large quantities in petroleum, refining, and metallurgy. Okay, so if I ask, which of the following acids is used in petroleum refining or in petroleum companies? Sulfuric acid, most importantly. Also, look, is used in the manufacture of fertilizer. Is used in the manufacture of fertilizer. Sulfuric acid is used in petroleum refining, petroleum companies, and in the manufacture of fertilizer. Done? Second point. It's also essential to a vast number of industrial processes, including production of metals, paper, detergent, dye, and many chemical raw materials. This is something like a general information about the sulfuric acid. Most importantly, sulfuric acid is used in the automobile batteries. In chapter 8, sulfuric acid is used in the automobile batteries. Let's repeat all the points. The first one is used in petroleum refining, also in the production of manufacture of or in the production of the fertilizer or in the manufacture of fertilizer. Second important point is used in the automobile battery. So the liquid inside of the automobile battery is the sulfuric acid, a highly acidic material. Fourth point, because it attracts water, okay, it attracts water. Sulfuric acid, it has a special talent. It has a special capability. It can attract water very strongly. That's why it's used as the effective dehydrating or water removing agent. So sulfuric acid, it attracts water, then is used as the effective water removing agent, okay, to dry something like what? Like the wet gases. So how to remove water inside of the gases? By sulfuric acid. Why? Because it attracts water. Remember. Let's repeat all of them. The first one is used in the petroleum refining and in the manufacture of fertilizer. Secondly, it's an essential material in a vast number of industrial processes, including production of paper, paint, dye, detergent, and also metallurgy. Okay, you know this. Third point, which is really important, is used in the automobile battery. And the fourth point, it attracts water. it attracts water, so it's used as the effective water removing or dehydrating agent to dry down the gases, to remove water in the gases. Think about the fifth point. Sugar and certain other organic compounds are also dehydrated by sulfuric acid. So sulfuric acid can remove water in the gases, in sugar, and in the organic compounds. Well, last point, skin. Our skin, as you know, skin contains something like an organic compound. So it can be dehydrated by sulfuric acid. So when skin, okay, any contact between the skin and sulfuric acid, it can cause a serious injury, serious burn. Okay, look, skin contains organic compounds that are attacked by concentrated sulfuric acid, which can cause serious burn or serious injury. You can check this in internet, acid attack in Iran. Good. I prefer to repeat all the points together. The first point, sulfuric acid. Sulfuric acid is used in petroleum refining. The second point, this is essential to a vast number of the industrial processes. Third point is used in the automobile battery. Fourth point, it attracts water. That's why it can be used to remove water in the gases, to dry the gases. Then, sulfuric acid also can dehydrate sugar and organic compounds like skin. Good. That was all about the sulfuric acid. Then let's take another one, phosphoric acid, or we can say nitric acid, but okay, based on the book, we go to take the phosphoric acid, H3PO4. Phosphoric acid, you should know this is a weak acid. Good. Phosphoric acid is a weak acid. Look, phosphorus along with nitrogen and potassium is an essential element for plants and animals. We need phosphoric acid for the bones strength. You have studied this in biology. Well, look, the bulk of phosphoric acid produced each year is used directly for manufacturing fertilizer. So this is the second acid that used in the manufacture of fertilizer. The first one, it was sulfuric acid. Then phosphoric acid is used directly in the manufacture of the fertilizer. Okay. Diluted phosphoric acid has a nice sour taste, and it's not a toxic. Okay. So phosphoric acid, it has an acidic taste, sour taste, which is not toxic. That's why it can be used as a flavoring agent in the example in the beverage or carbonated drinks or fizzy drinks. So which acid is used as a flavoring agent? Phosphoric acid. Which acid is used in the manufacture of fertilizer directly? Phosphoric acid. Which acid is used in the manufacture of the fertilizer? Phosphoric acid and sulfuric acid. Good. Nice. And the phosphoric acid is also important in the manufacture of detergent and ceramics. Good. So هر وەکو باسم کرد لە بۆ ئەوڕۆ بەس دوو دانیان دەخوێنین ئینشاڵڵا دەرسەکانی تر دێنین و ئانیتریشن دانە بەدانە دەخوێنین پرسیارەکانش of course we have to solve too many questions about them. Now it's time for the acids. As I told you, look my dears, in this chapter we will see all the basic ideas about the acids and the bases. Now it's time for the acids, starting from the strong acids. Look, first of all, acids including strong and weak, they are polar and electrolyte. Also, they are molecular compound, molecular electrolyte. Because you know, all the electrolytes are polar, including molecular and ionic. And they ionize in water. You know this. How to write the ionization for the acids? They donate their protons. Good. So, let's start with the first one, which is the strong acids. strong acid is one that ionizes completely. Okay, mister, I know this. Yeah, of course, you should know this. In aqueous solution, to produce high amount or more amount of the ions, I'm sorry, high amount or less amount of the ions, of course, high amount of the ions, since the acid is strong, so they have a weak covalent bond, which is easy to break, they ionize completely to release or to form a huge amount of the ions, which can cause the solution conducts electricity strongly. Good. Think about the following acids. My dears, I'm sorry, I'm not going to explain how to write their ionization reactions, because previously, in my previous videos, I have explained every single point about the ionization for the acids and the weak bases. So, you know, these are the reactions of these strong acids. These are strong acids, okay? As I told you, you should memorize all of them. Good. Plus H2O, because they are strong, so we will use the direct arrow to form the cation and anion. Since they are acids, so they donate their H into water molecule. Water, after receiving a proton from the acid, it will become H3O, and what left? The anion, the anion, the anion, the anion, the anion here. Okay, these are the anions that are remained after removing the proton from the acidic molecule. Then, okay, let's have a quick revision for something that already studied in the first chapter. Look, because they are strong, so the bond is weak, they ionize completely, there will be no molecule of the acid in the solution. We only get anion and cation, cation and anion, anion and cation, cation and anion, okay? So these are aqueous solution of the strong acids. Strong acid, AQ. So how many particles do we have in the aqueous solution of strong acid? Just say, mister, the strong acid itself will become disappeared, will become destroyed. I don't know how to say this. Burned liver? So we only get cation and anion because of the weak bond inside of the molecule. Good? Nice. Now we have this sequence. This is a really important sequence. Think about the bond between the hydrogen and the element. Look, if the HX bond polarity is increased, example HCl, the bond here, okay? If the polarity is increased, with increasing polarity, then the bond will become weaker. So as the bond polarity increased, the strength is decreased. Then, if it's weaker, it needs less energy. Then, it's easier to break. Then, the acid ionizes more because the bond is easier to break. It releases the parts of itself to form the ions. Then the acid is stronger. After this, we will get more ions. The first one is the hydronium ion, because you know these are ionization for the acids, which results the hydronium ion. I'll repeat these steps again. Look, think about the bond between hydrogen and the elements here, or the anion here, okay? As the polarity of this bond is increased, the bond will become weaker, then it needs less energy, easy to break, ionizes more, the acid is stronger, we'll get more ions. That's why we'll say the strong acid is the one that ionizes completely. Good. أوصل هاتو 2024 first term, okay? There is a question. The acidic strength depends on depends on what? One of the options, it was polarity between the hydrogen and the other element, the polarity. Okay, I have a question. HCl, it's a strong acid, right? Good. H2CO3, it's a weak acid. H3PO4, it's a weak acid. And the H2SO4, it's a strong acid. You know this, based on the list. However, HCl has only one hydrogen, but it's a strong acid. And H3PO4, okay, with 3 hydrogens, and it's a weak acid. So شتو اكو دبي دلما ما مسويك H here weaker. Our say H here stronger. Okay, my dear. Did I say acidity? Acidity, it means acidic strength. Look at this. Acidity. Acidity. Did I say acidity depends on the number of hydrogen or polarity? I said acidity depends on the polarity, not the number of hydrogen. However, it contains 3 hydrogens, but the polarity of the bond is less. So it ionizes partially, slightly. But this one, however, it has only 1 hydrogen, but because it has a highly polar covalent bond, so it ionizes completely. The bond is very weak. Good? So which one is important? Polarity of the bond or number of the hydrogen for the acidity? Of course, polarity of the bond. Good. Keep going, my dear. Look, we have 2 acids. HAE, which is a stronger acid than HB. This is a stronger acid. And this one, weaker. Weaker, okay? Stronger and weaker. Mister, this is a stronger acid. So it has more polar bond than this. It has less polar bond than this, the first one. Then the bond here is weaker. The bond in here is stronger. The bond in here, because it's a weaker bond, it needs less energy. But this one, the bond inside of or between H and B, since the bond is stronger, it needs more energy. Look, the polarity between H and A is greater, correct. The HA bond needs less energy. This is also correct. The HA bond is weaker, easier to break, of course. This is correct. D is the correct answer. I'll leave this for you. It's nothing. Keep going. How about the weak acids? Try to flip all the previous points for the strong acids. Okay, apply them to here, but in reversed way. In a reversed way, of course. Look at it. In there, the bond, it was more polar, but here, less polar. Look, so HX bond is less polar. Nice. Here, in there, for the strong acids, the bond was a weak bond, but here, it's a strong bond. For the strong acids, the bond needs less energy. Here, it needs more energy. Nice. Then, for the strong acids, the bond, it was very easy to break, but here it's difficult. It's not easy to break. In there, the acid ionizes completely, but here it ionizes. Look at this, please. Ionizes partially or slightly. So, for the strong acids, it was produced more amount of the ions, but here we'll get less amount of the ions. Cool. Look at this. Weak acid, an acid that releases few hydrogen ions because it ionizes partially. Hydrogen ion, okay, since it's a very reactive species, if you remember during the hydrated proton formation in the acidic solution, H plus cannot stay freely, so it will attack a water molecule to form H3O in the aqueous solution. Good? Look, HCN. HCN, it has a strong bond. So it ionizes partially. That's why we need to use the reversible arrow to get the ions by the molecule of the acid. But there's a very important point. For the strong acids, I say the molecule itself will become disappeared. But here, the molecule stays inside of the solution with the maximum amount compared to the ions. So now we will get the molecule itself, the anion also, and the cation. But the amount of the ions is less compared to the molecule. The molecule, it has more amount. Okay, mister. Now I have a question. If we have a strong acid in water, so how many particles do we get? Only the cation and the anion for the strong acid. The molecule itself, how about the weak acid? If we have a weak acid in water, we will get the weak acid itself, the cation, and the anion. The amount of the weak acid is greater than the ions. Good. Chip joining. I've explained every single point here. So read it, you know what I mean by the following points. Let's solve the following questions. We have 3 nice questions that are looking very delicious. Look, the first one, diluted aqueous solution of weak acid contains. Look, the acid is weak. So for the weak acids, we have the acidic molecule, it's the acid molecule itself plus, so we will get molecule plus cation plus the anion. But if the acid is strong, we don't have any molecule, only the cation and the anion. So is there any anion? Yep. Is there any acid molecule? Yep. Hydronium ion, it means the cation. So we will have the anion, cation, and the acid molecule itself. The right answer is D. This question, aqueous solution or aqueous solution of strong acid. Mister, we have a strong acid, so the acid molecule will become disappear. We only get cation and the anion. Good? Only anion and the cation. The acidic molecule, no, will become disappear. D is correct. In this reaction, dash has the maximum concentration. Of course, among them, among the following 3 particles, which one has the maximum amount? Look, even assume, even you don't know what is the HF. It's strong or weak, but based on this type of arrow, which is reversible, it indicates that the used acid is the weak electrolyte. It's the weak acid. So we will get itself, cation and anion. The acid molecule provides or remains inside of the solution with the maximum amount. So it has the maximum amount. Look, don't you remember? Phosphoric acid with 3 hydrogens is a weak acid, but hydrochloric acid with only 1 hydrogen is a strong acid. How is it possible? Yeah, mister, why not? Because acidity does not depend on the number of the hydrogens. We only need the bond strength, which depends on the polarity. Because HCl, it has a weak covalent bond, ionizes completely, but H3PO4, phosphoric acid, it has a strong covalent bond. Okay, so you know it ionizes partially. Okay, it's time for the bases. Nice. The bases. The bases. Aqueous solution of bases taste bitter, or you know, the Talatanian bases, they have alkaline taste. They taste bitter. But for the acids, the taste, it was sour or acidic. Bases change acid-base indicator color. Okay, they turn the color of the indicator into blue. But for the acids, it was red. Then, diluted aqueous solution of bases feel slippery. It means if you touch aqueous solution of the bases, you will have the same feeling as you wash your hand with soap. So they have a soapy feeling. If I say which of the following aqueous solutions feels slippery? So first, you have to identify the substance. Example, let me give you a question. Try to write this question. Write this question. Which of the following aqueous solutions feels slippery? A, B, C, D. The first one, NaClAq. The second one, NaOHAQ. The third one, HClAq. Lastly, none of them. Which of them feels slippery? Okay, Mr. Feeling slippery stands for the bases. So which of the following is a base? NaOH. NaCl, it's a salt. No. HCl, it's an acid. No. So only NaOH is correct here. Then, bases react with the acids. Hopefully you remember. I have explained this point with the acids. In there, I said, acids react with the bases to form salt and water. The reaction is called what? Neutralization. And the properties of first, second, and third point, no, they were disappeared. Same thing true here. Bases react with the acids to form salt and water, right? Then the properties that just described in previous 3 points, they will become disappeared. Good. Bases conduct electric current. Of course, all of them are electrolyte, but some of them are strong, some of them are weak. Strong bases, hopefully you remember, they are ionic, they dissociate. Weak bases, they are molecular, they ionize. I don't waste my time to recall the following basic ideas. Bases are polar and electrolytes. Strong bases are ionic compound, therefore they dissociate, but weak bases are molecular, so they ionize. Nice. Let's take the strong bases. Strong bases are ionic compounds. Strong bases are ionic compound and completely dissociate. They completely dissociate, but so if the ionic compound is, if we have a strong electrolyte that is ionic, it will dissociate completely. And if we have a strong electrolyte that is molecular, it will ionize completely, easily. So for the strong electrolytes, the both two processes of the ionization and dissociation must be completely. But for the weak electrolytes, the two processes of ionization and dissociation must be partially or slightly. Look, strong bases are ionic, so they dissociate completely. They decompose. They compose of hydroxide, anion, and the cation that mostly will be the group 1 and group 2 elements. About the naming of the strong bases, it's something very easy. Look, these are the strong bases. Group 1 plus OH, or group 2 OH by 2. Look, for the group 1, we'll take all the elements: lithium, sodium, potassium, rubidium, and cesium. For the group 2 elements, we only take 3 of them: calcium, barium, and strontium, or strontium, or strontium. All are correct. The naming is very easy. Name the metal, lithium, then name the anion, which is hydroxide. Lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide, calcium hydroxide, barium hydroxide, and strontium hydroxide. You know how to write their dissociation reaction. That chapter یکم زور بزوانی آنم explain کرده بود بابی من یوادارم نبیرد مابی اگه لبیرشد نمابی دوی بم بوری لیر رو دوباره نکمه. Okay. Group 1 elements in the periodic table are called the elements in the periodic table. I mean the elements for the first group are called alkali metals because they react with water to form a strong alkaline solution. They react vigorously or strongly, crucially, with water to produce a strong alkaline solution. I'll give you an example. So try to follow the same example, try to apply this example for the rest of the elements. The other elements, I mean. Sodium plus H2O. This is a single displacement reaction. دەبی لە پۆل 11 ئەوت خوێندە دەبی لە بیرت ماوی باشە. So it will be NaOH plus H2. I don't balance this. I'll leave the balancing for you. So you have to balance this. Try to use this reaction for the rest of the other elements like potassium, cesium, rubidium, and lithium. About the weak bases. Weak bases are molecular compounds. Look, weak bases. They are molecular compound. They ionize because they are weak. They are molecular, so they ionize. They are weak. For the sake of weak, they ionize partially. The process must be partially. They release few hydroxide ion. They ionize slightly. These are the weak bases. We have 3 weak bases for now, but later in chapter 10, of course, we'll take a bunch of other weak bases like the amines, the amines, okay? So these are the weak bases. We have only 3 weak bases for now: ammonia, aniline, and methylamine, okay? Let me take a sip of water, please. باسم کردیە کات خۆی چۆن ڕیاکشنەکانیان دەنووسی سۆ لێرە دووبارە دەبی بمبوری باسییان ناکەمەوە کات خۆی باسم کردیە how to write the ionization for the weak bases. I only explained the first one. Look, so bases they gain proton from the water molecule. Try to write water molecule like this for the weak bases. Bring the proton from the water molecule to the base to form the cation. What left? The anion itself. Because it's a weak electrolyte, it ionizes partially, so we will get the ions, but less amount of the ions, and the molecule of the base provides greater amount compared to the ions. درسی دابێ دیاڵە ئێستا ئەوش دەخوێنم ئەو پرسیارانە ئەو چەند نۆتەی لێرە باز دەکەم ئەو زە کۆتایی بەوانەکەی دێنین سەیرێرەکە بزانە. CuOH by 2 copper hydroxide has some small solubility in water, or it's okay to say it's insoluble in water. That's why it cannot produce. Look, therefore, it cannot produce a strong alkaline solution. أول وزارياته أبزام 2022 first term 2022-23 first term. Base's strength depends on the hydroxide ion concentration. Look, baseەکان چیمان لەو فۆرم دەکەن OH. baseەکان چۆنن؟ strongەکان چی بوون؟ ionic بوون، dissociateیان دەکرد. weakەکانی چۆن بوون؟ molecular بوون، ionizeیان دەکرد. So base کاتە baseەکان بە هەردوو طریقەی ionization و dissociation OH مان لەو فۆرم دەکەن. Bases are produce OH with both processes, ionization and dissociation. The one that produces more OH will become stronger. The one that produces less OH will become weaker. Here, organic compounds that contain nitrogen. Okay, how to recognize the organic compounds? Carbon plus hydrogen and now plus nitrogen. These are called nitrogenous organic compounds. They behave like weak bases. Be careful with this. And these points, you know, we have nothing new with these 2 points. Okay, we have nothing new with these 2 points. I have explained all of them. ئەو پرسیارانە وازبی خۆت حەلیکەوە هەمووشتم بە جوانی باس کردیا ئەو نۆتەیەش هەموو لەگەڵی باس کردبوو. So ئینشاڵڵا دەرسی دابێ لە definition of the acids and the bases لەگەڵتان بەردەوام دەبم. تاوەکات هەر شاد بن خواتان لەگەڵ.